Dynamic multi-point VPNs. Now in this section we'll get into some of the basic introduction of dynamic multi-point VPN, how it's going to work. Now if you just get back to some of the basics what we have seen, like the classic GRE tunnels, there are some major drawbacks with this one. Is it only supports point-to-point connections, and manually we have to configure the tunnel on both the endpoints, not really scalable, and also it doesn't support encryption. And we need to have a static IP address on each and every point, and if that IP address is changed, or if it is a dynamic IP address, in that case the tunnel will go down automatically. Now all these drawbacks we generally overcome, most of them, in these dynamic multi-point VPNs. Now DMVPN, again introduced by Cisco in the late 2000. Now this technology is going to allow you to have dynamic automatically created VPNs. Now automatically created VPNs means once we configure some of the DMVPN commands, it's going to build a logical tunnel. It's going to build between them, and it also allows you to have dynamically tunnels built between all the spokes. So which means by using some of the minimum configuration, we can have a full mesh dynamic multi-point. Full mesh VPNs can be implemented between this router 1 to router 2 and all the remaining routers. And also one more major advantage we get is on the spokes, that is on the router 2, on the router 3, on the router 4, we can have a dynamic IP addresses. Now dynamic IP address means something given by the service provider, keep on changing via DHCP. Now let's say the IP address is 25.002, probably the next day, even if it changes, still the VPN will work. So that's something what dynamic multi-point VPN supports. Now it's a technology which is more similar to frame relay kind of implementations, which allows you to have a multi-point VPNs. Like from one router 1, we can have multiple connections to different spokes. So it's more like a frame relay, hub and spoke terminology, where the GRE tunnels are built based on multi-point GRE instead of using a normal GRE tunnels. Like when you talk about normal GRE tunnels, the normal GRE tunnels will have a point-to-point connections. So which means, let's say if you want to configure from router 1 to router 2, we create a one separate point-to-point interface, and from router 1 to router 3 we have a separate point-to-point, and from the router 1 to router 4 we have a separate point-to-point connections. So that's something what a normal GRE supports. But whereas in case of multi-point GRE, what we are going to do is we'll have a source address, like we'll be using the multi-point source, but instead of destination we are going to use more GRE. So which means we can have multiple destinations on the same particular source interface. Now it's going to support some multi-point connections, that's what we call as multi-point VPNs, and it doesn't have any tunnel destination commands. So the major advantage here, again, it minimizes the configuration complexity. It gives some very good flexibility for providing multiple VPN connections, and also keeping the cost low. So this DMVPN implementation can be done by using different technologies. Now there are different technologies which will help for the DMVPN to work. In that, the first one is multi-point GRE interface. So multi-point GRE is more similar to a normal GRE. As I said, normal GRE, it's going to have only point-to-point connections, where we'll be going to configure tunnel source and tunnel destination commands. So which means for every tunnel source you will have a separate destination, like tunnel source, tunnel destination, tunnel source, tunnel destination. Like we have some, if you want to have 3 separate point-to-point connections, we are going to create 3 separate point-to-point connections by using a normal GRE. But whereas in case of multi-point GRE, what we are going to do is we are going to use point-to-multi-point connections, where we can have one particular source and we can have multiple destinations. So here we don't configure any multi-point, we don't configure the destination commands. Instead we use tunnel mode GRE kind of implementations. And then there is something called next hop resolution protocol, and we use some dynamic routing protocols. And optionally, if you want to encrypt your information, we can also use IPsec over dynamic multi-point VPNs. Now let's see one by one. First, let's go with a multi-point GRE. Now in case of multi-point GRE, there is no tunnel destination, as I said. Instead of using tunnel destination, we use tunnel mode command. So we'll be having a tunnel source and tunnel mode commands. So more on this, we'll get into that when we see the actual configurations in the command line. Now tunnel can have multiple endpoints. That what it means here. So whenever we configure tunnel mode GRE, instead of using the tunnel destination, your tunnel will have multiple endpoints. Like most of in my scenarios, I'll be using 3 separate endpoints, which means the router 1 is connecting to 3 different locations and it has 3 different points. That's what multi-point connections. Now the endpoints can be configured as GRE or multi-point GRE. Now it depends, like these endpoints, either we can configure it as a point-to-point or we can also configure as a multi-point. Now the major difference is, like if you configure this endpoints as a point-to-point, it will have a connection only to this router and it will not build dynamic tunnel between router 2 to router 3. So that's what we call as DMVPM phase 1. Phases, we'll talk about that more in detail in a separate video. Now we can also configure multi-point GRE. Now the endpoints, that is spokes here, we can either configure them as point to multi-point or we can configure them as point to point as well. Now the mapping, this mapping information, like how to reach that particular destination, because when we don't configure destination, now how this router is going to build a dynamic tunnel with this particular IP address. Now that information is given by some protocol called NHRP, Next Hop Resolution Protocol. So let's talk about the next protocol which will help us in building the dynamic multi-point VPNs. So the first one is a multi-point GRE we are using instead of a normal GRE, and the second protocol is Next Hop Resolution Protocol. Now Next Hop Resolution Protocol is more similar to your normal ARP or inverse ARP in the frame relay. So in case of Ethernet, we have some ARP protocol. What it is going to do? So if I try to ping to a destination IP address 10.0.0.2, now ARP protocol is going to resolve that particular destination IP into a MAC address before it reaches the switch. So the same thing happens here as well. Now here also, let's say there is a user who is supposed to communicate from router 1 to router 2. So NHRP protocol is going to provide the mapping of your private IP address to a public IP address. In case of NHRP terminology or DMVPM terminology, we call it as NBM address is mapped with a tunnel IP address. Now here what we are going to do is we are going to create one tunnel from router 1 to router 2, and then we are going to build, say that 10.001 and 10.002 is the IP address. Now the NHRP protocol is going to maintain the mapping information of, if any, this is the tunnel IP address, is mapped with the public IP whatever used on that particular tunnel destination. So that is 25.002. Now if there is a router here, the router 1 wants to communicate with 10.002, that is the next hop IP address. Now this router is going to send it to 25.002 because the NHRP is going to maintain that mapping information of your tunnel IP address to NBMA address. NBMA address is the actual IP address or the destination, tunnel destination IP address we can say. Now this mapping is maintained by your NHRP protocol. Now this information, either it can be built manually by the administrator, we can do this mapping manually, or we can allow the NHRP protocol to build this information automatically as well. So more similar to ARP. So the main job of the NHRP is to resolve the tunnel IP to NBM address, or it's going to maintain a database. In that database, it's going to maintain the NBM address mapped with tunnel IP address. Now based on this information only, your dynamic tunnels will build. So let's try to get into some more details on how it's going to work, how exactly NHRP is going to work. Now, if you want NHRP to work normally, either you have to do the manual mapping or dynamic mappings. So let's say if I'm using some dynamic mappings, we need to configure a centralized router as a next hop server. So we refer any one centralized hub, a router as next hop server, and all the remaining will be referred as clients, next hop clients, all the referred as next hop clients. So next hop server acts as a mapping agent which is going to store all your mappings. Now this server is going to keep all the mapping information of your NBMA address to tunnel IP address. So in my scenario, it will be like private to public IP mapping. Now, if any next hop client wants to communicate with any specific next hop server or anything, let's say the router 2 want to communicate with, let's say the router 2 IP address is 10.002 and this is 10.003 and this is 10.001 and 10.004. So we have some IP addresses more similar to formulae, and if this next hop server want to communicate with 10.003, that will be the next hop. In that case, it's going to send a query to the next hop server asking that the private IP address is 10.003. Now I want to reach 10.003. What will be the NBMA address? Like this server is going to maintain that information. It says if you want to go to 10.003, you have to go with this address. Now it's going to communicate with this one. So it's going to allow you to have dynamic VPN established, and this information is provided by the next hop server. So every client has to send a query message if they want to communicate with any other next hop clients. So the next hop server is going to reply to those queries which are made by next hop clients, that is the spokes. In simple words, it's more similar to your hub and spoke, where the next hop server will be acting as a hub and all the remaining will be referred as spokes. Now NHRP uses some different messages for information, like there is a message called NHRP registration request. Now this registration request is sent by the spoke. Let's say in my scenario, the router 2. The router 2, every spoke router, like in this case router 2, router 3, router 4, what they need to do is they need to register their own information with server. Because how the server is going to build the information, that's the question here. Like the router 2, whatever the IP address they are using, let's say in my scenario the tunnel IP address is 10.002, and whatever the public IP address they are using, so probably they need to register themselves with the server. So they need to provide their own information to the server so that the server can maintain that database information. So that's what we call as register request. Spokes must register their own NBMA address. NBMA address is, in my scenario, it is 25002, and then tunnel IP address. So tunnel IP address, let's say 10.002 to the next hop server. Now this is something which is required for them to build spoke to hub tunnels. So this is really required, it allows you to build tunnels from spoke to hub, and also it allows the particular server to have some information about the spoke NBMA address with their own tunnel IP address. Now then there is something called NHRP resolution request. Now this resolution request is sent by the spoke. It sends a query for the other spokes. So it's going to send a query to the hub router asking that if it wants to communicate with another spoke, what will be the NBMA address for that. And then there is something called NHRP redirect messages. It's something used in the DMVPM phase 3 implementations. In the advanced implementations, we'll talk about this more in detail, where the server is going to answer to the spoke that how the packet has to be forwarded, or it's going to intimate the short path to reach between spoke to spoke. Now these are the 3 different messages used by NHRP to provide information, or every spoke has to register their own information with the server, and then every spoke is going to send a query to the server for reaching the other spokes, and then finally NHRP redirect is answered by the server about the shortest path information from spoke to spoke.